Hello, my name is Phillips and I am a GIS consultant within the localization team, specialising in the supply and analysis of data. Today I am going to talk to you about the use of Python and Python packages within ArcGIS Pro, which can be used to enhance your data manipulation and analysis. I will start off today with a very brief introduction to Python and talk about the concepts of site packages and libraries. The main Python site packages I will be talking about today are ArcPy and Pandas. I will then present a demo of how to use Pandas for CSV manipulation, getting your input data into the correct structure as a precursor to performing your analysis. I will show how this can be done through both the Python window and Python notebooks. So, I hope the fact that you are watching this video means you have an interest in how you can make the most of Python within your day-to-day work, analysing and manipulating data. So, what is Python exactly? If you type this question into Google, you will get an answer along the lines of the following. However, in simple terms, it is an open source, easy to use and learn programming language, which can be applied to many different applications. Being open source means that users can write their own collection of modules, libraries and packages, which can then be imported into Python to provide additional functionality. Taking a look at this diagram, you can see that Python exists at a collection of levels, each one building on top of the next. Core Python itself is built on top of other programming languages. Ecosystem packages are written to solve particular sets of problems. These are designed to work nicely together, but they are fundamental, as other libraries are built on top of these. For example, Pandas is built on top of NumPy. At the top of the diagram, you can see high-level libraries, and this is where ArcPy fits in. Opening ArcGIS Pro and looking at the Python Package Manager gives an indication of the wide number of packages available, and these are only the ones that come pre-installed with Pro. Pandas is a package suited for working with structured tabular data in memory. This makes it an ideal tool to use when you have tabular data which isn't too large. If you find yourself wanting to work with much bigger files, then it may be worthwhile checking out Dask, as this can handle much bigger files because you're not limited by the amount of RAM you have available. So let's dive into Pro and take a look. Today I am going to be using Pandas to manipulate the house price data which is available from the Land Registry under an open license. I have downloaded the data in CSV format going back for the past 10 years. Opening up the Python window, I'm going to start by importing the packages we are going to use today, and I will import NumPy as NP because as coders we want to write the least amount of code possible. You will notice also that we don't need to import ArcPy. I am first going to open up one of my CSV files so I can examine it by using the read CSV command. Pandas will read this data into what it calls a data frame. I can now look at my Pandas data frame and look at the top few rows. However, you can see that using the Python window, this doesn't display my data very well, so instead I am going to visualize this using a Python notebook. Python notebooks can be opened up through the Analysis toolbox, and they allow you to create and share documents that contain live Python code, visualizations and narrative text. Having notebooks integrated directly into ArcGIS Pro allows you to perform analysis and immediately view results in a geographic context, interact with the data, add documentation and automate your workflow. If I type the name of my data frame into my Python notebook and run this cell, you can see it automatically knows what I'm talking about as a Python notebook is linked with the Python window. So you can see from this that our table does not contain headers, and there are a number of columns in here that we are not interested in. So what can I do about this? Using Pandas, I can tell it which columns I want to use and assign these column names on the fly. Now you can see my table is formatted nicely. I can see the number of rows in my table and the number of columns. I also only want to perform my analysis on one particular postcode area, so I'm going to choose SA around Swansea. So this covers one of my favourite places, the Gower Peninsula. I can do this by selecting all those records where the postcode column starts with the text SA. When I run this code, you will see that it comes up with an error. This is because there are null values within my postcode field. I can easily rectify this by telling Pandas to ignore any values that are null. As I have data for 10 years, I want to do this analysis for every CSV file. So I am going to write all this code into a loop using the arcpy.listFiles function, combine it all together in one single CSV. I can run this cell by pressing Shift and Enter, and you can see the asterisks showing up here, which means the cell is running. I can now use Pandas to perform some analysis on my data. Currently, I only have the transaction date as a single field, and I want to split this out into day, month, and year. I can do this by setting up a date time index on my transaction date field and then splitting this out into my 3 separate columns. I can then visualize just the top 5 rows of my data frame. You can see this has now added in my 3 extra columns. Now I am interested in looking at the numbers of transactions per month. I can do this using the group by functions within Pandas. Here I want to look at the number of transactions there were grouped by year and month. I can now do the same for the average price paid. As I mentioned at the start of this talk, Pandas is built on top of other ecosystem packages such as NumPy and Matplotlib. To show an example of this, I now want to plot my average house price data on a chart. To do this, I'm going to import Matplotlib, but I don't want to import the whole package, so I'm only going to import a specific part of it. So now I have my data, almost how I want to use it, except for one thing. In order to visualize this on a map, I'm going to want to geocode it. Firstly, I will create a single line address by joining multiple fields together. I will start by creating my first line of my address, as the house number had been separated out from the street name. I will infill any blank values with an empty string and join these together with a space. I will then create a single line address by adding in the town and postcode and joining these together with a comma. I scroll across my table, you can now see I have my full address listed. To geocode this dataset, I will use a locator that has been built using the latest version of Esri UK's UK data loader, using Ordnance Survey's address-based core dataset. This is the latest addition to the address-based suite of products and contains approximately 33 million local authority addresses and is updated weekly. I have added my CSV table into Pro, and I will now use the geocoding wizard. This guides me through the process of selecting my input table, the locator I am going to use, and selecting the input address fields. Once this has run, you can open up the Geoprocessing History window and export this as a Python command. This is a very useful function if you are not too sure how to type the syntax first off, especially where the tool involves field mapping like this one. This could then be inserted into a longer Python script, where the parameters could be altered as necessary. I now have a set of geocoded energy performance certificates, which I have pre-processed in a similar way to the house price data. If I open the EPC attribute table, you will see there are many columns in this dataset. I can list these all out using the arcpy.listFields function and print out the name and the type. I now want to join some of these fields from the EPC table across to my geocoded points. Again, there are many ways I could do this. I could use the Join Fields geoprocessing tool in ArcPy. I could read the data into a NumPy array and use the extend table method, but in this case I am going to use the ArcPy data access module, ArcPy search cursors and update cursors, and Python dictionaries. Python dictionaries provide a fast way to read data into memory and access it via an associated key value. I will start by adding the fields I want to update into my geocoded addresses using the ArcPy add fields command, which allows me to add multiple fields in one go. I am going to start by defining a couple of variables for my source table, where the join is coming from, and my update feature class, which is my geocoded properties, where I want to update the values into. I also need to define a field list. In this case, I have the same field names in both my input table and my output feature class, so I only need to specify one list. The first field in this list must be the join field. All subsequent fields are the fields to be updated. I am now going to set up my dictionary, my search cursor and my update cursor, which will go through, find the join between the source table and the update feature class, and update the values required. This is much faster than using a traditional join field geoprocessing tool. Opening my attribute table, you can now see this has been updated with the values from the EPC table. I now have a set of house price data geocoded to address level, enhanced with some additional attributes from the EPC dataset, which I can use in my further analysis. In summary, I have shown you today how data can be manipulated and enhanced using Pandas within ArcGIS Pro. If this has sparked your interest in how Python can help you with your day-to-day data analysis, there are many resources out there which can start you on your way.